Hi, today we're going to do another day of factoring. This time we're going to factor differences of perfect squares. Okay, and before we begin, I'm just going to see if we can come up with a little pattern here, if we can notice a little something. I'm going to start out with a couple binomials, and I'm going to FOIL them back together here. I'm going to do this kind of fast. I get x squared minus 3x plus 3x minus 9. And I want you to pay attention. What happens to these middle terms there? A negative 3x and a positive 3x, they cancel out. And I end up with x squared minus 9. Okay? Okay? Scooch up here a smidge. Look at this middle one. If I do the same thing, x squared, then I get a plus 6x and a minus 6x and minus 36. And once again, if you look at the middle terms there, what happens with those middle terms? Positive 6 and negative 6 go away. And essentially it's 0x here in the middle. Up here it was also 0x. But we don't write 0x's in the middle there. Just two terms, x squared minus 9 and x squared minus 36. Seen any patterns at all? Can I do the same thing with a's and b's? I get a squared minus ab plus ab minus b squared. And again, the middle ones go away, and I just end up with a squared minus b squared. Okay, so we're going to kind of take a look at this today, but we're going to be starting over here on the right. We're going to start with a little binomial, two terms. Notice it says difference was the title of this section, and difference we know means subtraction. And I have the difference of perfect squares. Okay, is x squared a perfect square? Yep. 9 is a perfect square. And remember, a perfect square is a number that has a nice square root. The square root of 9 is 3. The square root of x is x. X and 6. A and b. Well, what we're going to be doing today is we're going to be going backwards, like I said. Okay? And we're going to hopefully discover a little shortcut, a little pattern here that's going to make this actually be pretty easy. If I started here and I wanted to factor it into its two parentheses, look where it came from. X plus 3 and x minus 3. The first term, x and x, came from the square root of the first number, x and x. The 3's came from the square root of the last number, 3 and 3. And notice the signs. One is plus and one is minus. Remember, the opposites, they cancel each other out there in the middle, didn't they? Okay, x minus 36, x plus 6 and minus 6. A squared minus b squared is a plus b, a minus b. So really, we're going to be looking at the square roots of numbers. Okay? And the factoring is going to be a lot easier today. The middle term is going to be 0. Oops. The middle term has to be 0. And in order for the middle term to be 0, these have to be the same numbers. Only one is positive and one is negative. Let's look at a couple examples here. Okay? If I wanted to factor these, if I wanted to break them apart, you can kind of think of it as the same way as before. M squared came from m and m. Okay? And 64 has a bunch of factors on your factor sheet, but what we're looking at today is we're going to be looking at the square root of this number. The square root of 64 is 8. Okay, 8 and 8. And how do I get the middle term to be 0? Well, one is minus and one is plus, and it doesn't matter which is which. Okay, so this is pretty nice today. If you look at the one over here on the right, okay, 16, we know 16 has a bunch of different factors again, but what if I did the square root? The square root of 16 is 4. So it'd be a 4x and a 4x. 81's a perfect square. The square root of 81 is 9 and 9. And 1 is plus and 1 is minus. A 4x plus 9 and a 4x minus 9. Okay? So again, the factoring today should be kind of nice. How about these two down here at the bottom? Okay? If I was to do my two parentheses, the square root of 9 is 3x and 3x. The square root of 25 is 5. 5 and 5. And can you have a y squared at the back end? Sure. Is y squared a perfect square? Just like x squared is, we just put a y on the back end. One is plus and one is minus. Yeah, it works pretty slick. You might see a few like these today where it looks like it's in the opposite order. That's okay. We can write them in this order. The square root of 36 is 6 and 6. 49 is 7 and 7 and it has an a on it. One is plus, one is minus. Okay? But again, I'm going to point out, in order for this to work, they have to have a subtraction sign in the middle. Okay? It has to be the difference of perfect squares. If it's addition, it doesn't work. Okay, it has to be subtraction. Okay, and if that's the case, then hey, we're in business and this isn't so bad. Okay, all right, I got some special ones here. And what's special about this is, oh man, look at the power. Have we done x to the fourths before? Not yet. Okay, but is x to the fourth a perfect square? What is the square root of x to the fourth? It's x squared and x squared. Okay, if you do the FOIL-ing and you test it, x squared times x squared gives us x to the fourth. Yep. 81. 81 is a perfect square. The square root of 81 is 9. Okay? And you remember the signs? 1 is plus and 1 is minus. Now what makes these special besides the exponent being a fourth power? Well, once we get it factored and we factored it into a couple squareds, we need to look at those two factors and ask ourselves, can anything be factored any further? Okay, and if I look at these, I know x squared is a perfect square, and so is 9. Square root of 9 is 3. Okay, same thing over here. One of them we can continue to factor a little bit more. If you remember what I said a couple minutes ago, the one that has subtraction in it is the one that can be factored. This is one we saw on the previous page. Okay, that can be factored one more time. They're still perfect squares. The square root of x is x and x. The square root of 9 is 3 and 3. And 1 is plus and 1 is minus. Okay, so I could make that one, I could take that one step further. I can't do anything with this one because of the plus sign. It just comes along for the ride. X squared plus 9. And I actually end up with 1, 2, 3 parts to our answer. Okay, like I said, this one just comes along. Okay, but anytime we see them separated by subtraction, that's a big clue that we might be able to take it one more step, especially if they're perfect squares. How about over here? I'm thinking of my perfect squares. Does 16 have a nice square root? Yeah, the square root of 16 is 4. I could do 4w squared and 4w squared. And a lot of times people forget about little old 1. Is 1 a perfect square? Sure. What's the square root of 1? If you tried it, the square root of 1 is 1. So it could be a 1 and a 1, and 1 is plus and 1 is minus. And you remember, when I go from the fourth power to the second power, especially on the subtraction one here, I want to see if I can take it one more step, one step further. Do I have another perfect square here? In other words, is 4 a perfect square? Yeah, the square root of 4 is 2. 2w and 2w. 1 is still a perfect square, 1 and 1. And 1 is plus and 1 is minus. Okay? I can't do anything with the plus one. That one just comes along for the ride. 4w squared plus 1. And once again, I end up with 1, 2, 3 parts to our answer. Okay, so again, we're breaking them apart, and what we're doing is we're doing the square root of the first number and the square root of the second number. Okay, and then we're looking for the subtraction one, and we're doing the square root of it again and again. So we're looking for those perfect squares. Okay, I think I have a couple more down here at the bottom. Can we try these ones? To me. Okay. Okay, oh, a couple big numbers here. Okay. Okay. Well, how about this? Can I break it apart? I know y to the fourth is y squared and y squared. What about 625? Is it a perfect square? If you tried the square root of 625 on your calculator, you're going to see that it tells you it's 25. It is a perfect square. And 1 is plus and 1 is minus. Okay? And always look at the minus one, especially the minus one, and say, hey, do I have perfect squares? Can I do it one more time? I sure can. Y squared can be y and y. 25 is a perfect square. Its square root is 5. And again, 1 is plus and 1 is minus. Yep. And this guy just comes along for the ride. Y squared plus 25. 1, 2, 3 parts to our answer. Okay, yeah. If I look at this last one, same type of thing, but I have b's on the back end. That's okay. We can add variables on the end as well. Okay? But I like the number 4 and I like the number 25. 4 is a perfect square. It's 2 and 2. And a to the fourth would be a squared and a squared. 25 is a perfect square. The square root of 25 is 5. And b squared and b squared. 1 is plus and 1 is minus. Okay? Now let's hold up here one second. Okay, so I broke it apart. I was able to factor it into those two pieces. And as I said before, we want to check out the minus one. Okay, we know it has to be the minus one. If we can do anything, it has to be that one. But can that one go any further? Okay, it cannot. And the reason it cannot go any further is because 2 is not a perfect square, and neither is 5. They don't have nice square roots. That's the end of the line. We just have 2 parts to our answer right there, and it's going to be squareds in them. Okay, and that's perfectly fine. Okay, but we can keep going one more time if they happen to be perfect squares. If they're not, that's the end of the road. Done. Okay. All right, so again, it's the same thing. They just had bigger exponents. Those were the special ones. Okay. We talked about this in the previous lesson. One thing we can do to make our factoring a little bit easier is oftentimes we can factor out a greatest common factor. Now, when I look at this, this has x to the 5th. Okay. I don't like x to the 5th. It's not a perfect square. And how about this? Is 5 a perfect square? Nope, it doesn't have a square root. Neither is 45. But both of those terms have something in common that I can factor out. And if you look at the numbers, 5 and 45, 5 goes into both of them. And if you also look at the variables, they each have an x in common. I can take out a 5 and an x. Okay, and if I divide out a 5 and an x, this leaves me with x to the 4th. And 45 divided by 5 is 9. And the x is gone, so all I have is a 9 there. And once we take out this greatest common factor now, we always need to look at this leftover stuff and ask ourselves, well, hey, can that be factored any further? Well, this looks kind of like the ones we just did a minute ago. It's a perfect square. X to the 4th is a perfect square. It's x squared and x squared. 9's a perfect square. It has a nice square root. It's 3 and 3. 1 is plus and 1 is minus. Okay? And then once again, I always look at the minus one. Okay? But I can't go any further here because that's, well, x squared is a perfect square, but 3 is not. So that's the end of the road. And Mr. 5 up here, 5x, he just comes along for the ride. And we end up with 1, 2, 3 parts to our answer again. Okay? But we're going to try and continue to factor things, to break them down, and break them down, and break them down, and factor as much as we possibly can. Let's look at these guys. Do they have a greatest common factor? Okay? I think a 9 goes into both of them. And they also have a couple a's. A 9a squared goes into both of them. And if I take my 9 out and 2 of the a's away, I have a to the 4th. And 36 divided by 9 is 4. And both of the a's are gone. So I just have a squared minus 4 in that part over here. Oops. Okay? Now, again, let's look at this leftover stuff. Can that go again? A squared is a perfect square. I'm sorry, a to the 4th is a perfect square, and so is 4. So I think I can. A to the 4th goes to a squared and a squared. The square root of 4 is 2. 1 is plus, 1 is minus. And again, I'm going to look at the minus one and ask myself, can I go again? A is a perfect square, but 2 is not. That's the end of the road. And this guy comes along for the ride, 9a squared. So today, on these little bigger ones, we might have to do the factoring thing twice. And then we end up with 3 parts to our answer. Okay? But look for that greatest common factor. We want to simplify things first. It makes the number smaller and easier to work with. Okay? Got a couple more down here at the bottom. If you want to, you can try pushing pause and maybe try these by yourself and then unpause and come back in. Okay? If you want to, go ahead and push pause. Okay? Unpause and let's keep going. These have a greatest common factor. There's a 2. 2 goes into both of them, and they also have y to the 4ths. So I can take out a 2y to the 4th, and what's left over? Oops, you know what? I think I copied that wrong. Shoot. This was supposed to be a 2. I'm going to switch that a second. Instant replay. That's supposed to be 2y, or 32y to the 2nd. Okay? I can still take out a 2. Sorry about that. But the most I can take out is 2 y's. Okay? And if I take the 2 out, it's gone. I get a y squared left over. And 32 divided by 2 is 16, and the y squared is out front. Okay? And this right here, I have 2 perfect squares left over. A y and a y, a minus 4 and a plus 4. and my 2y squared comes along for the ride. Okay, there we go. Okay, this guy, it has a common factor. I think 2 goes into both of them. And I get a to the 4th, and 50 divided by 2 is 25. Okay? And again, I think this can go again. A to the 4th is a perfect square. I could do a squared and a squared. Plus 5 and minus 5. And then the 2 comes along for the ride there. Okay? So yeah, look to take out the greatest common factor. It makes the number smaller. And then it's perfect squares. That's the name of the game today. Okay? All right. Okay, oops. Did I mess that up? Oh, that's what I did. What did I do there? Okay, oops. Here we go. Grouping. Okay? We talked about grouping the other day, and when we do grouping is when we do 4 terms. Okay? So let's try this one. So I'm going to do grouping again. And remember, we group the first 2 numbers together and the last 2 numbers together. Okay? And then when there was a subtraction sign, there was one special thing about grouping. When there was a subtraction sign in between them, we had to change the sign on the very last number. Okay? Let's see what we get here. What we do then is we look for a greatest common factor, and I think I can take out a 7x squared out of both of those. And I would get an x plus 3 left over. Okay? On this one, I think I can take out a 7. And I get an x plus 3 left over. Okay? And the name of the game with grouping is they had a little expression in common. And I can take an x plus 3 out of both of those. And what's left over, when I take that away and that away, I have 7x squared minus 7. Now the other day when we did grouping, we kind of stopped right there. Okay? But today with grouping, we always have to look at this leftover stuff and see if we can factor it just a tiny bit more. And here again, they also have a greatest common factor. I can take a 7 out of that. And when I take a 7 out of that, I get x squared minus 1. And this might look familiar. I could even take this one more time. This turns into x plus 1 and x minus 1. They're a difference of perfect squares. Okay, so holy mackerel, look what I have for my answer here. I got an x minus 1, an x plus 1, a 7, and an x plus 3. This one has 4 parts to our answer. Okay, but the name of the game with this grouping thing today is, once you do the grouping and take out the common expression, look at this leftover stuff right here. They're oftentimes going to have another greatest common factor, and the leftover stuff you can split apart again because they're perfect squares. Okay, those are a little bit tricky. We're going to try one more of these grouping ones. Have it right down here at the bottom. Let's see if we can tackle this one. Okay, let me erase this up here. Okay, let's try this. What if I group the first 2 terms, the last 2 terms, and remember I see a minus sign, so I got to go to plus again. The first terms have a greatest common factor, and if you look at your factor sheet, the biggest number that goes into 6 and 30 is a 6. And I think I can take out 2 of the x's, an x squared. And what's left over is an x plus 5. Okay? If you look at your factor sheets here, the biggest number that goes into 24 and 120, okay, I think is 12. Nope. Actually, is it 120? Yeah, actually, 24 goes into it. The whole thing. I'm going to take out a 24, and I get x plus 5 left over. Okay? If you look closely, grouping, they both have an x plus 5 in common, so I'm going to factor that out. And the leftover part is 6x squared minus 24. Okay, and again, when we did grouping the other day, we were done because this was not factorable any further, this part. But here, they have a common factor again. I can take a 6 out of that. And I get an x squared minus 4 left over. Okay? And this stuff in the parenthesis, one more time, is a difference of perfect squares. An x and an x. The square root of 4 is 2 and 2. 1 is plus and 1 is minus. And that's the end of the road. So what do I have for an answer here? I've got 1, 2, 3, 4 parts again. And you can write them in any order. I guess it'd be best if you could write, I like writing the big number out front. And then the rest of the terms can be in any order. X plus 2 and x minus 2. But it has all 4 different pieces. Okay? So factoring is a fun thing. Okay? It takes a little bit of practice, but once you get used to it, once you get the hang of it, it's not so bad. Okay, that was by grouping. All right, here's the very last thing. The last thing they want us to do is they want us to solve quadratic equations by factoring. And this is kind of similar to what we did before in the last section, but we're going to do it with these perfect squares. Okay? Let's first of all factor them apart into their two pieces. 9 is a perfect square, 3y and 3y. 36 is a perfect square. We could do 6 and 6. 1 is plus and 1 is minus. Okay? And now we want to solve it. So if you remember solving, it wants us to find the zeros. And there was a shortcut that we used to find the zeros. If you remember, it was the opposite of this number. So negative 6 divided by 3. Oops, and I shouldn't have done that. Okay? In this case, it can be simplified. Negative 6 divided by negative 3 is negative 2. Okay, and I could do the same thing with the other one here. It'd be positive 6 divided by 3, which is positive 2. Okay, so I get 2 and negative 2. We're just going to go the one extra step. It's set equal to 0, and let's find the solutions. Okay, here's another one. Okay, now bad news. 8's not a perfect square, and neither is 32, so I can't just do the square root of them. Well, then what do? What you do next is you look for a greatest common factor. I could have actually done this on the first problem as well, but this one, I need to find what is the biggest number that goes into 32. Well, if you look at your factor sheet, 8 goes into 32. And if I divide out an 8, I get a y squared minus 4 left over. And the name of the game is looking at the leftover stuff today. Okay? I can do y and y. The square root of 4 is 2. I can do a plus 2 and a minus 2. And if I was to factor it, I'd just bring down my 8 and I'd be done. But now, since it's equal to 0, I want to find the solutions. Well, these are a little bit nicer than the last ones. If you remember, it's just the opposite of whatever's in there. Positive 2 became negative 2. Negative 2 became positive 2. What about the 8? Does the 8 have anything to do with the solution? No, it does not. Okay, not the solutions. The zeros have to have a variable on it. And there's the second one. Okay? And there's one last one here. This is the very last one for the day. And then we're done. How about this guy? Now, if you remember when we did factoring and solving in the two previous lessons, before you could do any factoring at all, we needed to have a 0 on one side. And right now, this is out of order. Okay? Now, it doesn't really matter. Ultimately, it doesn't matter which side you move everything to. But we also talked about keeping the x squared term positive. It's easiest to factor when the x squared is positive. So with that being said, and x squared is on the right, and that 25 is positive, let's move everything to the right. Let's move the 100 over here. And let's put our 0 on the left. And that's perfectly fine. Let's subtract 100. Okay? Now again, I always look for a greatest common factor. Okay? If I look closely here, I think 25 goes into both of those. If I factor out a 25, 25 goes into 100 4 times. And then here's that, this one appears quite often. If I factor x squared minus 4, they're perfect squares. I could do x and x, minus 2 and plus 2. And then my solutions would be a positive 2 and a negative 2. Okay? Now, that's probably the best way to do it. I know there are some of you who are thinking, well, hey, 25 is a perfect square and so is 100. We could have done the square root of that and gone 5x and 5x. Plus 10 and minus 10. The square root of 100 is 10. And then I could have done my solutions, but it'd be negative 10 over 5, which is negative 2. That's that one. And this one would be positive 10 over 5, which is positive 2, which is the other one. And the order doesn't matter. Okay? But I think if I was to remember one thing, always, always, always look to factor out a greatest common factor. It makes just makes all the other numbers smaller, fewer choices, and the factoring, for lack of a better word, a little bit easier. Okay? All right, thanks for tuning in.